In this example, we're being asked to solve the system of equations using the addition elimination method with back substitution. So in this example, we're going to be able to combine pieces of the elimination method with substitution, which can actually become quite convenient for several problems, including this one. So let's take a look at our system here. As you can already see, this is three equations with three unknown variables. So our first equation, I'm going to call it equation 1, is positive x minus 2y plus 3z equals 9. Equation 2 is negative x plus 3y plus nothing equals negative 4. And then our third equation is positive 2x minus 5y plus 5z equals positive 17. Now, one thing I want to point out, notice how I'm trying to write this organized. I have stacked my x variable column together, my y variable column together, z together, so on and so forth. So when you have more complicated systems, the best course of action is to express these systems in an organized fashion, as organized as possible. Okay, so let's go ahead and get started with the solution. So we're going to have to do a couple of elimination methods. The first thing I want to do is, again, we're going to create some kind of convenient elimination. The way I'm about to do it is not the only correct way of doing it. You may find a way that works better for you, but we're going to do it the way I already have worked it out in my notes. So, but again, if you have a better way of doing it, that's fine. You can do it a different way. Just use the combination of elimination method with substitution. So the first thing I'm going to do is I'm going to use equation 1 to create a cancellation in equation 2. So at first what I'm going to do is I'm going to use something in equation 1 to create a cancellation in equation 2. And doing this will change equation 2. Okay, so here's what I'm going to do. I'm going to say, let's do equation 1 plus equation 2 in order to eliminate x in equation 2. Okay, so again, it's the same kind of process we've seen with two equations and two unknowns, but it is going to be a little more complicated. Okay, so the first thing I'm going to do is I'm going to rewrite both equations. X minus 2y plus 3z equals 9, and then we've got negative x plus 3y equals negative 4. And I'm going to not mess with equation 3 for now, okay? I'm going to leave equation 3 alone for now. So we can create this convenient cancellation. We see you have positive x and negative x wipe each other out. And then what are you left with? Well, you're left with a y plus 3z equals 5, okay? Now, this is going to be the new equation 2, okay? So look at my wording here. I said use equation 1 to create a cancellation in equation 2. This will change equation 2. And so what we did was we said equation 1 plus equation 2 in order to eliminate x in equation 2. So we have basically formed a new version of equation 2, okay? Now, we're going to keep equation 1 the same, okay? So now what we have, now the system is, go down to the next page, it's x minus 2y plus 3z equals 9. And now we have a new equation 2, y plus 3z equals 5. And remember, we have not messed with equation 3 at all yet. So equation 3 is still 2x minus 5y plus 5z equals 17, okay? So again, this is equation 1 remains unchanged. Equation 2 has been changed now, and equation 3 still remains unchanged. Okay, so this process is actually the same when we had two equations with two unknowns, but it may feel a little different for now because we do have a third equation with a third variable, but stay along with me for now, okay? The next thing I'm going to do is I'm going to now use equation 1 to eliminate x in equation 3. Okay, so now what I'm going to do, again, I'm going to use equation 1. I'm not gonna change equation 1. I'm going to use equation 1 to eliminate the x term in the third equation, and this will thereby change equation 3. So we're going to end up getting a new equation 3. So watch what I'm doing this one step at a time. I'm going to rewrite equation 1 now, just to be very organized. And then below it, I'm going to put equation 3, just so I can show my steps on how I'm eliminating terms. Okay, now how do we create some kind of elimination here? Well, we need to multiply both sides of equation 1 by something in order to eliminate the x in equation 3. What should we do? Well, I would say let's multiply both sides of equation 1 by the number -2. Okay, right? Is that going to work for us? Yeah, absolutely. So what does this temporarily become? Well, we end up with a -2x plus 4y minus 6z equals -18. And then equation 3 is still 2x minus 5y plus 5z equals 17 for now. And we go ahead and add these together, and we see the x term cancels. And what are we left with? Well, we're left with a negative y, sorry, minus z equals -1. Okay, and this becomes the new equation 3. So what have we done? We've used equation 1 now to modify equation 3 somehow. Okay, so what is our system going to look like at this point? The overall system is now ... x minus 2y plus 3z equals 9. Again, we have not permanently changed equation 1. Equation 2 from several steps ago was y plus 3z equals 5. And now we have a new equation 3 of -y minus z equals -1, okay? And so, again, equation 1, all we've done to equation 1 is we've used equation 1 as like a tool to modify and change things in equations 2 and 3. So now, what's another step we can do? At this point, this is our system. At this point, we can now use equation 2 to eliminate the y in equation 3. Okay, so we can do a similar kind of thing that we just did twice actually, but we're using equation 2 now to create a cancellation of the y term within equation 3. And we can see that that's already pretty much set up for us, okay? So we could say, y plus 3z equals 5, that's equation 2. And then minus y minus z equals -1. It's already really set up for us. We can just directly add these two together, and we see the y's cancel themselves out. and you end up with 2z equals 4, okay? And then clearly we end up with z equals 2 here, okay? So now what is the overall system? Well, this is, even though it's very simple, this z equals 2 is the new equation 3. So what is the system now? Now the system is what? Well, it's x minus 2y plus 3z equals 9. And then it's the second equation is y plus 3z equals 5. And then we just got a brand new equation 3 of z equals 2, okay? And so this is our updated system with equation 1, an updated equation 2, and then a double updated equation 3, okay? Now we can use, conveniently, we can use substitution, okay? So we can say now it is easy to use what's called, it's really called back substitution. So how do we do this? Well, we know z is equal to 2, so we substitute this z equals 2 into this equation here, and we solve for y. And then we'll have a number for y, and we'll substitute the value for y and the value for z into equation 1 and solve for x. So let's do that. Let's say, we're going to say substitute z equals 2 into equation 2. And we'll get y plus 3 times 2 equals 5. Okay? And so what do we get? We get y equals -1. And now we say substitute z equals 2 and it's not x, y equals -1 into equation 1. And that way we'll solve for x. So we end up with x minus 2 times -1 plus 3 times 2 equals 9. And what do we end up with? Let's see, we get x equals 9 minus 6 is 3, plus 2 is, 9 minus 6 is 3, minus 2 is 1, right? 9 minus 6 is 3, and then this is a positive 2, move it to the other side, so it's -2. So the solution is consistent and is x equals 1, comma y equals -1, comma z equals 2. And you would box all of this in with a straight edge, and that is the conclusion of this example.